Deb's asking me, she's like, after lunch, do you have any joke? I said, the first joke is, can anyone pronounce my surname? And you did it brilliantly. It's Codinhoto. And here I am, a Brazilian with Italian descent, and I will use my hands as much as I can here. And yeah, that's me, a bit of crazy. And the first thing of this is I want to introduce this idea of the fornocere, which is a concept that is introduced by Professor David Cooley in Bath, which basically means ugly through harm. And we say that for us to start making change, we need to start changing the concept that we use for aesthetics. And beautiful is not beautiful if it causes harm. So I think the core is that of the research that I'm trying to do. So, and then every time I talk about BIM, and people come with the fancy 3Ds and walkthroughs, it reminds me of we know political agenda here, Angela Merkel rolling her eyes when she's speaking to Putin, and then, like, oh, 3Ds and walk it through again. So I'm not showing that, so even though that's part of BIM, right? And I think FM goes a lot more into the data that you have and how can you use that data as the structured data rather than geometric information. And we can benefit as a society. So a little bit for those who are not familiar with the journey of BIM. So a lot of effort has been put on CapEx projects, which is when public institutions, they commission new buildings. And the operation side has almost been untouched or unpacked in terms of using of the data. So basically you have a design team producing large amounts of data, and then you have a contractor producing even more data. And then when it gets to handover, hardly, only a small amount of that information goes through the system and is used to manage facilities. And I find that is wasteful. So we can try to optimize that. So in this research, we focus on waste and waste management because we thought, well, it's an area that hasn't been looked in. Is there something that I can do? I'm an architect by background. I love design buildings, and I said, the way I design buildings, they will influence the way people use them and the way pollution is generated and so on. So just a little bit of data, 2.2 billion tons of waste generated per year in the world, 99% of products disposed within 6 months. Landfill gas, 6% is CO2, 40% is methane, that is 25 times stronger than CO2. Right, so yes, I think we are in a route to improvement, but I think we can do better. So on this came to this idea of working with university campus as part of complexes, building complexes, right? So I work with universities and hospitals, which is the area of my interest. And I decided to look at the University of Bath, which has 118 buildings with over 20,000 people using those facilities every day and generating approximately 280 tons of waste per year. That includes general and recyclable waste. Worth to mention that Bath and the council, BAINS, has a very good track record for not sending any waste to landfill, right, which is excellent, but still we need to work hard in terms of reducing the amount of waste that is generated. So the idea of a BIM bin came to talk about, well, what can we do to help students to reduce the waste they generate, but also to help facilities manager with this difficult task that is to maintain public assets in a time where, there's shortage of money to run their facilities. There are higher KPI, the KPIs are strong, so you need to save money and be more efficient. And we try to tackle a little bit of both in this small project. So just a quick going through the literature. There's almost nothing there in terms of BIM for waste management. So you see the governance practices, resource recovery, social environmental behavior, and now we start talking about reuse and recycle as part of a longer time cycle, but not much that use data to inform decision-making processes. And in designing of our research and thinking about information modeling rather than the building of BIM, building information modeling, we say, well, we need to map the flows of people, we need to map the flows of waste, the flows of service, and the building geometry, and see how these things are interconnected. So we've done a little bit of a background research trying to understand, okay, so everybody's talking about BIM, EIRs, BEPs, and all of that, and we analyzed the extent that the information in those documents was related to facilities management. And we found almost nothing that was related to that, so basically the information that is going through may help quite a lot of hard FM, which is the maintenance of fabric, but the operation of the building itself is not incorporated into these documents. And then just, you know, some images that we don't see that. If you walk on campus, right, they're all well hidden, and then, you know, the campus is clean. But then in every building that you use, there will be a place like that that we tend to avoid, right? And I say every time you avoid something, or you tend to take for granted that if you put the waste in the bin, it will disappear, that is an opportunity for doing research, right? So you need to investigate further what is happening to that. And here I was. So we interacted with the facilities management team of the University of Bath, and they kindly provided data to us so we could measure in terms of volume how much waste was generated and where it was displaced within the campus. And here started our experiment. So we choose the library building, particularly in exam times. It's a building that has high occupancy, and as you would expect, large volumes of waste being generated. So we use some space syntax tool, just trying to understand, you know, where these bins were located and what the relationship was with users. And here we start entering a little bit on the social science side of this research. And as it's intuitive to think that you have to put the bin in the most visible place, right? But then if you're doing that, actually you're incentivizing people to generate waste and displace it, right? So we have to learn the hard way that actually the best approach is to start hiding the bins, because then you make uncomfortable, you may be thinking about why you are uncomfortable in trying to find a waste bin to put something. And therefore, yeah, actually, I should not generate waste, not in the library, to say the least. And also, we monitored data in terms of occupancy. So we use a simple device. The logs of mobile phones on the Wi-Fi network, so we could identify how many people were per floor within the building, even in a specific region. So we're shifting that to Bluetooth. That gives us a specific point without any data breach. So we don't know who these people are, and we don't need to know. We just need to know how many people there. And also we looked in terms of crowd footfall analysis to see where are these people going. No surprise there. So when we looked into the waste generation, right, so we could see there are two peaks during the day, right? So at lunchtime, the bins would be full, some of them. And at lunchtime, after the collection, they start filling again to a lesser extent. So the way we've done that was a very non-digital way, right? So we created a ruler that was the size of the bin, and we were there taking measurements just to generate the initial data to see if we could get any insights. Yeah, the lack of technology didn't prevent us from moving forward. So we looked, we spoke to the actual team working in data and waste collection. And so they had this cycle of waste collection twice a day. And we start questioning, is that the most efficient way of using your time? Right? Not all of the bins are full, so you don't need to collect all of them every day. And so with a little bit of lean production principles, we devised a system that was better in terms of using the work of someone who has already a day very busy with other activities to do to collect the waste that we are generating, right? It's a little bit of a kind of colonial thing that, you know, you just assume that someone has to come and collect and take it from there for you. So we had to model the building. That is the kind of the 3D that we generated, but not just generating a Revit model for the physical location of things. We had to understand through using the Dijkstra algorithm the relationship between volume of waste being generated and the location of that bin, also the Voronoi diagram to see which rooms within that space were kind of more likely to use a particular bin. And I know, very complicated waste management system, but we're digging, right, to trying to find the solution. Then we use Dynamo here we use the shortest path algorithm to try to understand and revert the logic of it, right? To try to understand what would be the best solution to collect. So let the computer to design the best route for waste collection to let us know if there would be any improvement on that. And here are some of the key results. So we found that on the 3rd floor, which is where this work started, we had 16 days per year of wasted time, right, that could be economized. So it's 80 days per year, the whole library, and 9.5 thousand days of the university if you consider all the 118 buildings, right? I'm going to talk about later a little bit about, you know, why is it worthwhile making that savings, and it is, anticipating the result. And here is something that we've done to continue the work on the social science side of it. Because we understood where the waste was being generated, right? So we knew what the hotspots were. We target some educational interventions in those spots, and it is short-term data, right? So we cannot say that this is a pattern. But we saw a reduction of almost 50% in the generation of waste in that area just because we had an educational intervention there. Right, so what we've done was we put the bins on sensitive scales. If you drop the pin, there was a screen that you saw, do you know 2.2 billions of waste a year? Are you doing something about it? Right, and then there was someone there just to explain a little bit more of the projects. There were flyers as well. And yeah, I think people got the idea. Students understood that, yeah, we are at the top of the formal education and we need to do better and lead by a true example. So this was our idea of the nudge impact. So moving a little bit further in terms of the technology, so then we developed this device, which is basically an infrared sensor that we put together. And you can see high technology used to connect it to the bin, right? So and basically what we would do, as you start throwing waste on the bin, that would send the information of how deep, how much that bin was filled with. And so that was made available online, and then we connected that data with another Dynamo code, which we call the Kanban Dynamo code, which is, again, lean production Kanban system, which would tell us physically, right, which were the bins that were fulfilled, and then the porters would be only targeting those, saving time. So if I can get that to play, I'm not sure how I would do this, perhaps here. Yeah, sorry, bear with me a second. And yeah, there you go. This is done, in this case here, it's just done manually, but it was connected to the data in the cloud lively, and then you would see, you know, every bin that becomes red, it means 50% of its capacity is full, it should be collected, right? And based on the algorithm before, the path for collection would be drawn automatically, knowing what you can do with that information and how much time you can save, and so on. So then we started looking into other buildings, and we realized that we didn't need the LOD 500 so much talked about in BIM literature to model this. And actually we found out that the university has about 6 different types of models for waste collection. And then the gains is not as much as I presented earlier on, right? So this needs adjusting. But again, the science is not there. We are developing as we speak. So it was insightful to think about that. And more importantly, the way this could be useful is a university is like a mini city because it has different types of buildings, different types of users, right? So, and the idea is that we are collaborating with Bath City Council, and then perhaps we could replicate that at city scale, trying to save the pounds that is necessary at this time when councils are suffering for shortages of income. So of the conclusions, there's basically some the common things that we know. Current available information suffice for waste information model, so we didn't generate anything new, right? So everything is there, it's just the way we capture that. The Internet of Things can increase accuracy of a waste management system, and significant amount of time can be saved in waste collection, and the digital systems support the reduction of waste, which is the most important thing that we want to target on. Right, so one of the problems that we have is the legacy of data that was generated 5 years ago, how that, we inform systems that are being implemented now. So the next steps of this research as we move forward, so we are modeling the whole campus, trying to understand this as a system, and then try to make something generic that can be used by other places. And one of the ideas that we are exploring, some of you may have seen on BBC News, these wheels that they are like actually robots. And so it's a simple idea, so if you connect that with the shortest path that we have, so the bin could collect itself and go somewhere where it should be, right? And then we've been discussing ways of doing, perhaps the bin should have arms saying, you should be saving or not wasting too much. And another thing is this idea of mapping flows, right, has led to, when I presented work, other people contacted me and led to explore other areas, right? On the BIM FM and IoT side, I'm working with the University of São Paulo in Brazil and the Politecnica di Milano as well. And we're looking into reactive maintenance, and this is the part that comes important, right? Medium-sized universities, they have on average 35,000 reactive maintenance service orders per year, right? And this shows the strain that facilities managers are going through to maintain old stock buildings or even new buildings. Milan in particularly, they have 400,000 service orders just to maintain their schools within the metropolitan area, right? So, and then if you could save those little amounts in waste management, so then you could invest elsewhere. So this idea of mapping flows as well, I've just submitted a proposal to investigate loneliness, which is it's something that affects 1 in 20 people. All right, so we will be developing a piece of research in Australia investigating how this idea of monitoring people and user behavior can help us to support people suffering from with loneliness. And finally, again, another piece of project with the University of São Paulo, we looked in terms of a fire evacuation. So by sharing data, we found out that the algorithms do not consider vulnerable people evacuation times in the way that it should be. So we looked into schools in particular, and just to pick an example, a child using that guardrail, you won't see the top of it, you will see the hose through it. And that is something that stops the speed of coming downstairs in the occasion of a fire, in the event of a fire. So we've done the research already, we show that that is the case, right? So, and then, again, it's all based on the same principle of using the data that we have. Last but not least, a lot of people to say thank you to. So the students that Debs mentioned earlier, so also the team from the University of Bath who kindly shared their data with us. And I have 1 minute 30 that I wanted to leave with this to read. This is from John Neutra, the son of a famous American architect, Richard Neutra. Unfortunately, he passed away last September, but in 1984, on the building Survival Through Design, a book written by his father, he mentioned how fast technology can evolve, but how slow are we to adopt this technology in making significant changes. Right? This was the message within this book, and I think that is true. And I think it relates to what, the importance of the work that BRE Trust is doing in terms of a guide policy, which is what drives change. Right? So we need to focus on, not just on the lab and developing the technology, but also implement what we're doing and make, get the gains where they are available for us to improve society. So that is me with 33 seconds to spare. Thank you very much.